Hello. In this video, we will introduce the concept of fluid saturation. The concept of fluid saturation can be explained through a glass filled with different fluids, as we will show. The first glass is filled entirely with water, meaning that the entire pore volume, in this case glass volume, is occupied by water, and thus the water saturation is 100%. Fluid saturation is the volume of a particular fluid divided by the pore volume. The second glass is an identical glass and is occupied by both water and oil. Here, the water saturation cannot be 100% as the oil is sharing some space with the water. Finally, the third glass has water, oil, and gas in the same glass, and thus the saturation of each fluid will be less than 100%. Similarly, rocks are filled with one or more fluids. Fluid saturation helps us quantify the amount of hydrocarbons or water in the rock. We can classify the saturation into three categories: water, oil, or gas. Water saturation, SW, is the volume of water in a rock divided by the pore volume. Oil saturation, SO, is the oil volume divided by the pore volume. Finally, gas saturation, SG, is the gas volume in a rock divided by the pore volume. The summation of saturations of all the fluids in a reservoir has to be 1, as the pore volume will be filled with at least one fluid. If a reservoir contains water, oil, and gas, then we have SW plus SO plus SG equals 1. However, if a reservoir only contains oil and water, then the equation will reduce to SW plus SO equals 1. Although this equation is very simple, it is helpful in finding an unknown fluid saturation mathematically. This figure shows an example of a microscopic rock slice illustrating water, oil, and gas saturations in the pore spaces. Similar to porosity, fluid saturation is important to estimate the amount of hydrocarbons in a reservoir. However, it is important to distinguish between porosity and fluid saturation. Porosity tells us the maximum storage capacity of a medium, while fluid saturation depicts the exact amount of fluid occupying the pore spaces of the same medium. For more information, check out my textbook and booklet on reservoir rock properties, along with my lecture notes, all provided in the description box down below. Thank you for watching, and I'll see you in the next video.